my screen. Thank you for kind invitation to speak at this meeting. And let me introduce our talk, heat exchange impact on NML logging while drilling. Prepared in the Institute of Chemical Kinetics and Combustion of Siberian branch of Russian Academy of Science and Novosibirsk State University, in cooperation with colleagues from Baker Hughes, Oleg Bocharov, Radu Koman, and Holger Tern. About the NMR logging while drilling, a few words. The transmitter sensor part of the NMR logging while drilling tool consists of two permanent magnets shown in blue and receiving transmitting coil shown in red here, and sensitive volume green at some distance from the borehole wall. The characteristic rate of penetration is around 20 meters per hour, and bit sensor offset in the case discussed in this presentation was 20 meters, which means that the time since drilled was about 1 hour. Again, this slide, sorry, this few words about the NMR logging while drilling. The permanent magnets shown in blue, transmitting, receiving coil shown in red, and sensitive volume shown in green is on some distance shown here from the borehole wall. And rate of penetration in this presentation is 20 meters per hour. It can be different. And the transmitter and the offset of distance between the bit and the NMR sensor is 20 meters. So the time since drilled is around 1 hour. The NMR the Courier Langevin law describes the macroscopic nuclear magnetization, and it is inversely proportional to the absolute temperature shown here, T. To detect the NMR signal, well-known car parcel Merbium-Gill sequence is used that consists of 90 degrees pulse and series of 180 degrees pulses. The consequent echo train is detected. To describe heat transfer in formation, a heat conduction equation in cylindrical coordinate frame is used, and where T is the rock thermal conductivity or thermal diffusion, T is the absolute temperature. The solution of this equation for the dimensionless parameters tau T shown here and rho, where A is the borehole radius. The solution is the next. And for small time, the small time expansion is on the bottom, shown in the bottom, where J and Y are Bessel and Neumann functions. The numerical modeling of this solution is shown here. There is a comparison of solution 1 and 2 for small time expansion and solution itself for borehole temperature versus radius of two different values of the dimensionless parameter tau t, 0.3, 1, and 3. For example, 0.3 for thermal diffusion coefficient equal to 1.01 square centimeters per second for times drill is equal to 1 hour. For borehole radius around 11 centimeters. The heat conduction equation considering mud invasion is shown here, where V is the rate of mud invasion in near wellbore formation. In cylindrical coordinate frame, V is shown here. And where V0 is constant is a filtration flow rate at the borehole wall at R is A, equal to A. In dimensionless form, this beta is shown here, is in cylindrical coordinate frame, the equation is like this. For constant boundary conditions, for constant boundary temperature T1 and initial formation temperature T0, the solution looks like here, where J and Y are Bessel and Neumann functions of the order beta. The convection parameter beta has to be obtained from the solving the filtration problem. To solve this problem, the conduction equation for the pore pressure in cylindrical frame is used, and for cylindrical frame is shown here. For dimensionless parameters, tau dp is proportional to the permeability and inversely proportional to the viscosity, porosity, and compressibility of formation. And for initial, for boundary pressure conditions, P1 at the borehole wall and P0 in the formation, the solution is shown here. This solution is and the numerical modeling of this solution is shown also. There is an equation and the mud invasion rate versus time since drilled for different permeabilities. 1 millidarcy, 10 millidarcy, and 100 millidarcy, shown in yellow, red, and blue. And the dashed line is for characteristic time of the NMR measurement, 1 hour. Here is the equation for convection parameter beta. And this equation, and it's the numerical modeling, is convection parameter versus times is drilled. Also for different permeabilities, 1, 10, and 100 millidarcies, and dashed black line is 1 hour times since drilled, equal to time of NMR measurement for this example, for our example. The next is a comparison of the temperature the temperature profile versus distance for different permeabilities. 0, 1, 10, and 100 millidarcy. And black dashed line is the sensitive volume distance. Here shown the comparison of temperature versus time since drilled for different permeabilities. 1, 10, and 100 millidarcies. And for these permeabilities, convection parameter for 0 also, of course. And for these permeabilities, convection parameter is 0, 0.25, 2, and 17. There are parameters used for numerical modeling of temperature effect on NMR signal. The borehole diameter, 21 centimeters, the sensitive volume diameter, 33.5 centimeters, diffusivity, 100 centimeters, square centimeters per second, viscosity, also 100 points, the compressibility, porosity 20%, and pressure different, 20 atmospheres, and thermal gradient, 3 kelvins per 100 meters. And here we is shown temperature versus vertical depth of real formation, real borehole, for interval 1,215, 1,239 meters, and blue points are measured temperature in borehole. Black dashed line is temperature of formation of virgin formation estimated from geothermal gradient, and the red line is the temperature of sensitive volume by our numerical modeling. Here is the NMR signal, Cochrane signal versus time for the same interval, depth interval, and you can see that it is a permeable interval, and there is some difference between experimental points shown in blue and dashed line obtained by our calculations. The difference is several percent. Nevertheless, this is for penetration, for drilling rate, for penetration. They name this penetration rate 20 meters per hour. The rate of drilling penetration rate can amount 100 meters per hour and even higher. So it is 5 time difference or even bigger. So this effect can amount several up to 10% probably. Moreover, the permeability usually estimated using some Coates equations and other equations proportional to porosity in power 4. So the effect of heat transfer can amount several tenths of percent for permeability. Here it is the temperature of borehole formation and sensitive volume. Borehole, it's blue, sensitive volume is red, and black dashed line in the temperature of virgin formation estimated from geothermal gradient, and also in magneto is shown here the permeability from NMR logging while drilling data. You can see that for permeable intervals, the temperature of borehole and temperature of sensitive volume is almost the same, but for low perm intervals, there is a difference.
Excuse me, 2 minutes.
Conclusions. An analytical solution has been obtained to assess the effect of temperature in mud invasion zone of the NMR logging while drilling signal. The model includes the treatment of convective heat transfer for permeable layers invaded by mud filtrate. The theoretical results show that due to the mud invasion to permeable zone, the temperature of NMR logging while drilling sensitive volume is close to the measured temperature in the borehole or the mud temperature. Thank you very much, and greetings from Siberia.
Thank you for the interesting presentations.